Hey, welcome back everyone, here I am again. Let's take a look at how we can simplify with roots. And now we have theory B in here as well, which means we have to be careful about the difference of adding and subtracting roots, which we can only do when we have like roots, which mean the same number or letter inside the roots, and multiplying, which is always possible because you can always simplify a multiplication, asterisks attached, in lower grades. Let's take a look. 8 root 3 minus root 3. Those are like roots. And here we have 6 root 3. Hey, those are also like roots. So if I want to, I can do this subtraction and this addition in one go. If I have 8 root 3 and I subtract 1, remember you could say there's a 1 here. It's a terrible 1, but it's there. You have 7 root 3's, and then I add 3 root 3's, so then I find 13 root 3's. The number inside the root stays the same. Again, you could visualize it is almost the same kind of question as saying 8a minus a plus 6a, with the same rules attached. You can do this only because they're all things with a. You have 8a's, minus a is 7a, plus 6a is 13a. And now you see that the rules for working with letters or with roots are actually kind of sort of the same. Okay? So this is comparison. 2 root 7 minus root 2 plus root 7. Hey, only addition and subtraction, so I should check, is this feasible? No, not everything, because you can see that those two things have the same root combination, but this one is different. That's okay, because I can still add the two orange terms up. 2 root 7 plus root 7, remember that's 1 root 7, so a total of 3 root 7. And then minus root 2. Mind you, I would also find it correct if you would say minus root 2 plus 3 root 7. Swap the two terms. That would be totally fine with me as well. Okay, but the negative sign is attached to the root 2. So keep it there and then you get a plus because 3 root 7 is positive. Okay. At C, 3 root 2 times 2 root 6 times root 3. This is times, this multiplication, so I can always do this. I don't have to check for like roots, just do it. You can do this in one go. What you can do is multiply the numbers in front of the roots times each other. 3 times 2 times, you could say 1, again, if you so prefer. 3 times 2 times 1 is 6. And then take a look at the numbers inside of the roots. And here I have 2 times 6 times 3. And you can put it in there as well if you prefer to do so. Or you can do it in one go and calculate. 2 times 6 is 12, times 3 is 36. And then people say, yeah, I'm done. And then I say, no, you're not, because root 36 you can calculate. Always check if you, in the end, can calculate root. Root 3 I cannot calculate. Root 2, root 7, But root 36 is just 6. And then the answer here is actually 36. Okay, remember there's a times sign here. Let's take a look at D. 3 root 2 times 4 root 5 times 2 root 10. Times multiplication. So first do the numbers in front of the roots times each other. 3 times 4 is 12. Times 2 is 24. And then inside the roots, you do the numbers in the roots times each other. Here it will be 2 times 5 times 10. 2 times 5 is 10, times 10 is 100. And again, please don't stop here, because root 100 you can calculate. What number times itself is 100? That's 10. So the answer here is 240. See? E. 5 root 2 squared. Hey, now we're combining the rules from the previous theorem. 3 root 16. Okay. This is a product sorry, a power of a product. So if you watch the video of 31 or you're practiced enough, you know that you have to square both the things inside the brackets. So 5 squared and root 2 squared. 5 squared is 25. Times root 2 squared, the root and the square cancel each other out, so it's 2. Minus 3, and root 16 is just 4, right? You can calculate that, which means this is the same as 50 minus 12, also known as 38. Okay? This looks more like a question you could find from theory A, but it's totally fine because on the test they will also be mixed and matched. So then you don't know which theory to apply where. F. This one is going to throw everything at the kitchen wall. 3 root 2 times root 5, so we have a multiplication but also a subtraction and also a power. Okay. Let's try to do this. Well, you could say one step at a time, but you can do multiple steps at a time if you want to. You can first do this and then also assess this in the same step. Let's try to do that. The numbers, first of all, multiplication, so I can simplify this. Remember, you could say there's a 1 in front here. 3 times 1 is 3, times 2 times 5 is root 10. Okay? And 3 times root 10, if you want to, you can immediately write down, is just root 10. This you cannot simplify because root 10 is not a nice root, right? You cannot calculate mentally which number that would be. Then here, square both things. Minus 2 squared is 4, because remember, minus 2 times minus 2 is positive 4. Here the root and the square cancel each other out. And then you have this. And this freaks people out, because surely we're not done, but yeah we are, because those are not like roots. This one has a root, this one doesn't. And you cannot calculate root 10, so this is just an okay answer. 3 root 10 minus 12. You just stop here. Okay? And that's it. Practice this well, please, because again, if you do not know how to do arithmetics with roots, then I think a chapter that's called squares and square roots is going to be quite difficult. Okay? Good luck.